Okay, let's start talking about the friction force. So this is something we've been talking about a decent amount in class already, but it's time to really get this hammered home into our minds. So the friction force is a force that opposes the motion of an object along some surface. The surface could be a table, could be an ice rink, could be the surface of a pool of water, but the friction force opposes the motion an object tries to travel along the surface. And it has a range of values. So it has some minimum value of 0, right? So if the object's not moving and there's no forces exerted on it, right? If we just have a block sitting on a table, that table's at an incline, so that's a bad attempt at drawing it there. But, if we have a block on a flat table, there's no force that's trying to push it along the table. So if we have a flat, relatively flat table, right, there's no force trying to move this block, right? The only forces acting on the block here are the force of gravity, pulling it down, and the normal force that's opposing it, pushing it up. There's nothing that's trying to push it in this direction along the surface. So there would be no friction force. All right, let's assume, though, you tie a piece of rope to the block, like here, and you're pulling on the block, but you're not pulling hard enough to make the block move. You now have a friction force. It's not as large as the friction force can get, but you have a friction force, and it's what's preventing the block from moving, right? Because we know if you apply a force that's unbalanced, right, if we have a net force, it should accelerate, all right? Clearly this one's not, no movement. So the force that's opposing that is called the friction force here. They're equal and opposite to each other. Let's say, though, you pull a little bit harder on the block, right? That means the static friction force is going to get bigger. This is not as big as the static friction force can get. There's a limit to it, okay? Depending on the type of surface, there's a limit to how big the static friction force can get, right? And here, we see when movement just starts, we've hit the limit of the static friction force. So the static friction force will not get any bigger than this, okay? Now you could increase this force, then the object would move faster, right? It would accelerate more. Okay, so we just said that the static friction force, friction static, has a range of values, right? It could be 0, and it could be some high number, but it's never going to be larger than the normal force. Okay? So the static friction will not be larger than the normal force of an object. Okay. The reason is we can represent the maximum static friction force. So we're going to call this friction force, like this is the friction force static maximum, is equal to some coefficient times the normal force, and this coefficient is between 0 and 1. Okay? So the friction force here can be anywhere from non-existent, like in this case, up to the normal force, assuming the surface is extremely rough and it doesn't, assuming the surface is extremely rough, you can approach the normal force. Okay? So a good example of that type of surface would be rubber on dry concrete. So we've got some values of the coefficients of friction. Here, this coefficient of static friction for rubber on dry concrete, this one right here, is roughly 1. So that means that the maximal static friction is going to be 1 times the normal force, and you'll get that the static friction is simply equal to the normal force in this case. Okay. Different objects have different static friction forces. So if you want to find their static friction force, you'll simply, and this is the maximum static friction force. I need to clarify that. It doesn't mean that it's always going to be mu times the normal force. And I guess I should say that this symbol is called mu, right? And it's equal to, or it is, the coefficient, I can spell coefficient of static friction. Okay. And it allows me to find the maximal static friction force, the max. So if the object has begun moving right? If the object has started moving, it means that this force has beaten the maximal static friction force. If the object has not started moving yet, so like this case, okay, then you know that this friction force is not maximal friction force, you can see here. Okay, that's all I have time for in this video. I'll see you in the next one.